Good morning, everybody. Welcome back. It's Mr. Chen again. Today is Wednesday, March the 10th. In this video, what we're going to do is continue on with our new lesson on trigonometric ratios. From your textbook, this is found in chapter 5, found on page 273. And again, hopefully, what we're eventually going to do through this cycle, we're going to take a look at trigonometry. You've learned this in grade 10, but I understand we were having some issues with the pandemic, and many of you might have forgotten some grade 10 content. And so this lesson is just to get you up to speed, and by no means it will fulfill everything. So you need to kind of practice. I do recommend, though, you look at the getting started questions, and hopefully you'll be able to answer questions 1 and 5, and maybe even question 8. But don't feel bad if you don't remember everything. So I'm going to refresh us. Also, we are going to hopefully talk about 5.1, which again is found on section page 276. And hopefully these examples might assist you. So hopefully everyone can see this Word document that I've decided to give you some notes and talk about some basic trigonometry. Now, even before we start anything, even though if you did the getting started questions already or not, I actually try to teach my students, especially in grade 10 and 11, what to do when you're given any triangle. Now, just a couple of things. Seem to be very, very subtle. But vertices of the triangle, which are the points, are always labeled with capital letters. So in this example, I've decided to label this A, B, and C. So this is called in triangle ABC. So we use capital letters for the vertices. Now, vertices are just the points. So what about the sides? Again, what I'm going to do is label the sides. If you want to pause the video, go right ahead. But I think a lot of you know what I'm going to do. The sides of this particular triangle will be as follows. This will be side A, this will be side B, and this will be side C. Let's just take a moment and how we're going to do that. For example, let me just say we had this non-right triangle. And let's just say we had this triangle D, E, and F. So the first thing that every student should be able to do is label the sides, or going the reversed. If I gave you the sides, can you label the angles? So this side that I'm going to label, and feel free to pause the video. This side will be side F, this side will be side D, and this side will be side E. If you can't do this, you're going to have a very difficult time, especially in the grade 11 trigonometry. I'm just going to erase this example because I want to talk about this triangle. This triangle, of course, is a right angle triangle that I have in triangle ABC. And a lot of you know this because of the right angle marking in the angle C portion. So there's a couple of names that we have to associate. Now, it actually depends on the perspective. So just to emphasize the perspective, I'm going to circle angle A with the orange circle. And this is the perspective of we're going to name the sides. One more time. Notice the labels don't change. However, the names might change. What does that really mean? I think everyone agrees from grades 7 and 8 that you've learned that the longest side of a right angle triangle, this side is known as the hypotenuse. And I'm just going to use HYP for short, hypotenuse. It is the longest side. It is always opposite to the right angle. Notice, again, from the perspective of angle A, side A is known as the opposite. And I'm going to just use OPP. So that's the name of this side for this triangle with the angle A as its perspective. And finally, most of you, this is the new word for a lot of you. Side B, with respect to angle A, this is known as the adjacent side. And I'm just going to use ADJ, adjacent. Adjacent means next to. Now let's think about it for a second. The hypotenuse is also next to angle A. Why isn't the hypotenuse also the adjacent? So this causes some students a conundrum a little bit. But a lot of you realize that the side C, in this example, it's the longest side. So that's why it's the name that way. If we were to change the perspective, and I'm going to circle angle B, Notice side C is still the hypotenuse, and so that's its name. Side B is now the opposite to angle B. And notice what happened? Side A is now the adjacent side. And yet the labels stayed the same. So I'm going to erase this green example here, but I think a lot of you know what I'm doing. It depends on the perspective of the question. Now, some of you might have a question about what happens if we're looking with respect to the angle C. That's a very good question. And notice we do not ask that. Normally, we do not really care if we're going to look at angle C. So notice the perspective is usually of one or two of the other angles. Our next thing is actually talk about the trigonometric ratios. Now, in trigonometry, this is a little difficult to explain, but in math, trigonometry really is looking at the unit circle. Don't get me wrong, the word trigonometry is related to triangles, and that's why we use it, and that's how we introduce it in grade 10. But in mathematical context, the word sine, cosine, and tangent are related to the angles and its corresponding ratio of sides. So the short form for sine, and I know it seems weird, it's just S-I-N. The way that we pronounce this, though, I know it spells the word sin, but we don't say that. We call it sine. So the perspective we're going to use, and again, one more time, is we're going to use angle A. So the sine of A, its literal mathematical definition, is the opposite side over the hypotenuse. Now let's pause for a second. I'm not pausing the video. Notice we're taking some kind of mathematical operation on an angle, and it is equal to the proportion of sides. Let me give you a specific example. Let's just say angle A was 30 degrees, and this was side 1, and this was side 2. And just to tell you this really, really quickly, if I were to ask you what is the sine of 30 degrees, without using a calculator, a lot of you would say, from this diagram, it is the opposite side, so that is the 1, over the hypotenuse, that is the 2. What I'm trying to share with you, and it's kind of difficult, that we're taking a mathematical operation of an angle, and notice the reason why it is an angle is because we have a degree sign, and these are a ratio of sides. Hopefully you actually kind of understand that. And if we have to, don't get me wrong, I will talk about it in class. This is just to help everyone out. Let's keep on going with our definitions. Let's take cosine. Cosine, the short form for cosine is cos, C-O-S. And again, we're going to use the angle A still. And its definition is the adjacent over the hypotenuse. Finally, tangent. I'm running out of room. I should have planned this a little bit better. Tangent, the short form for tangent is tan, T-A-N, of the angle, and it's equal to the opposite over adjacent. So a lot of you have remembered from grade 10, there's a mnemonic that a lot of you use, and it's SOHCAHTOA. So let's take a look at this triangle one more time. Now let's take a look at its labels. So the sine of A is literally A over C. And again, I know there's no numbers. How about the cosine of A? Well, it's B over C. And how about the tangent of angle A? It is A over B. I would not memorize the one I wrote here. That is not what I'm trying to show you, but that is the answers for that question. If you want to pause the video, please feel free to. But let's see if someone actually can answer this question. What is the cosine of angle B? What ratio would I write? And a lot of you can actually do this. If this is angle B, notice that side B is the opposite side. This is the adjacent, and this is still the hypotenuse. So the definition of cosine, it's the adjacent over hypotenuse. And so we are going to find the adjacent side with respect to angle B. That's what this means. So angle B is our perspective. And what am I going to write? I think everyone agrees you're going to write A over C. Now let's pause the video for a second, or not pause. Let's stop for a second. And some of you are noticing something interesting. So some students want to know the history, like why? Why are these words here? And it's a mistranslation from the algebra. It's from the Arabic, because that's where we got a lot of this trigonometry. And basically, notice that sine of angle A and cosine of angle B, notice they have the same ratio. And if you really, really want to know, that is actually why they're called sine and cosine. There's a relationship between them. Now, a good question that some of you might have had in grade 10, if we're talking about these ratios of SOHCAHTOA, and ratios technically mean they're interchangeable, meaning if we do an example of another ratio, let's just say a class has 2 boys for every 1 girl. Technically, you could say 1 girl for every 2 boys. That's a ratio. So there is another trigonometry ratio that we're going to teach you. And this is why we do this in grade 11. So let's just recap really quickly. These 3 are called the primary trig ratios. So there's a secondary trig ratio. And they are as follows. Their names are, and let me just scroll this up just a little bit. And I might write over in the space over here to the left. Well, no, I'll just keep it down below so people can see it. So the first one is called cosecant. I know it seems weird. The second one is called secant. And the third one is called cotangent. The short form for cosecant, notice we've been taking the first 3 letters, right? For sine, cosine, and tangent, we took the first letters. If we were to take the first 3 letters of cosecant, it'd be COS. And unfortunately, that's already been taken because of cosine. So what they did mathematically is they took the first 3 consonants. So the short form for cosecant is CSC. So we're going to use cosecant of angle A. And what is this ratio? And I think some of you are going to figure this out. I'm going to write down in terms of their names. So maybe I should just keep the same colors. So cosecant of angle A, notice what its ratio is? It's the hypotenuse over the opposite. Now, some of you are already noticing these secondary trig ratios, if you look at your calculator, they don't seem to have these buttons. They don't seem to have the CSC button. They sure have a sine button, they sure have a cosine button, and they sure have a tangent button, but no cosecant. And we'll explain this in a moment. So let's keep on going. The short form for secant, it's SEC. And so most students say secant still. And I think a lot of you are already figuring out what I'm trying to do. The ratio for secant is the hypotenuse over the adjacent. And finally, the short form for cotangent is COT. So the cotangent of angle A, it is equal to adjacent over opposite. I apologize for running out of room on your screen. So if you need to pause the video, look at the screen, that's okay. So these are called the secondary trig ratios. So let me give you an example. Let's just say we have this triangle. Notice it's a right angle triangle. I'm going to name it D, E, and F for their vertices. And just to help everyone out, this is side D, this is side F, this is side E. And my question, just to make sure everyone's okay, let's try to practicing just working with the secondary trig ratios. Let's see if someone actually can tell me, or pause the video, what is the secant of angle F? What ratio would we write? So pause the video if you have to. And here's the answer. So angle F is our perspective, And so let's just name this information. Secant is, by definition, the hypotenuse, and this is the hypotenuse, it's the longest side, over the adjacent. Which side is next to angle F? Well, angle D is. So that's the hypotenuse over the adjacent. And many of you won't have to write them out. But what ratio are we going to write? I think everyone agrees. We're going to have E over D. Okay? In a moment's time, we're going to talk about now how do we actually find angles and how do we find sides. So what we're going to do is actually now use trigonometry to find angles and how to find sides. And it's pretty straightforward. If you look at your notes from grade 10, you should have no problem. But let's just make sure we have this refresher. I'm going to share my screen with you. So we're just going to go sharing screen so everyone can see things. And again, I have my Word document here, and we have our calculator. So hopefully everyone got a chance to purchase the Sharp calculator. Notice what I'm trying to highlight here with my cursor. Your calculator should be set in degrees. This is very, very important. If it's not, go to this button, DRG, and if you push that, if it says RAD or GRAD, means it's not in degrees. So first thing, before we do any of the trigonometry questions that we're going to make up in a moment to find either angles or sides, make sure first of all our calculator is in degrees. Notice again, we have sine, cosine, and tangent. And above it, notice we have sine to the -1, cosine to the -1, and tangent to -1. If you're watching my previous video, you already understand that this is the inverse or the opposites. Now we'll explain this in a moment, but hopefully a lot of you are paying attention. So let's just do one question about how to find an angle. So let's just say we have, let's say, sine of angle A is equal to 3 over 7. So notice what I did. I gave it to you in exact form, this ratio. Now, some students like to visualize things. So I like putting my triangle like so. It's just a sketch, a right angle triangle there. I like putting my angle here in the left-hand corner. If you don't do this, that's not a big deal, but I just find it very hard to do any other questions. And there's a reason why I'm doing it this way. So what am I going to do with the 3 and the 7? So put the 3 over there because that's the opposite side, and 7 is the hypotenuse. Right? So how do I find angle find angle A? Well, many of you realize if you constructed this with a ruler and you had a protractor, why not just measure it? That's great. That's called doing math with constructions. However, we're trying to be armchair mathematicians. And so we want to just use the math that's in front of us. So the way that we're going to do this, to find angle A, if we have a ratio, is we're going to get rid of the operation of sine. This is why, one more time, we try to teach you properly in grade 9 and 10, is whatever you do to one side, you must do to the other side. So in order to get rid of this sine operation, you're going to perform the inverse sine to both sides. And watch what we get. We get angle A, which is equal to the inverse sine of 3 over 7. Now that's what you're going to write, but how do you actually use your calculator? So notice we are going to get an angle. It's going to be approximate, and I'm going to show you. So I think the question was inverse sine, and notice what it shows, hopefully on your display. I like putting in the brackets, 3 divided by 7. Notice what I'm trying to really teach you, when you want to find an angle, you always do the inverse. What are we going to get? Pause the video if you want to, make sure you have your calculator, press equals, and we get the answer, 25.376. It keeps on going, and no one memorizes this. In the olden days, your grandparents, I don't think your parents, but your grandparents, they might have actually, when they were doing their math and trigonometry, they would have to come up to the front of the room and look in a textbook, a huge textbook that had all these ratios. This answer is 25.37. And we'll do 25.37 degrees. It keeps on going. Now, some students want to know what I'm going to do. So let's make the triangle just a little bit larger. And let's just say this was still angle A, and this was still 25.37 degrees. Still put a right angle there. Some of you want to say, well, why are you doing this, Mr. Tan? Well, I think some of you understand what I'm going to do. If this was 6 and this was 14, we would still get the same answer. What you were supposed to figure out from grade 10 is that these two triangles that I've drawn, and again, if you're not too sure what I'm looking at, oops, this triangle and this triangle, they are similar. How do I know they're similar? Well, because angle A is 25.37, so these are the same, and these angles are the same. So that, therefore, by deduction, the third angle is a congruent. And yet the triangles are different sizes, but the proportions are the same, right? I think a lot of you understand this, that this triangle, the one, and I should have used a maybe different color, but this triangle here, I'll start this one. If I were to ask you, what's the ratio of sine of A, ignoring the 25.37, you would say, Mr. Chen, that's 6/14. But we can reduce this fraction to 3/7. Slowly, some of you are realizing this is why or where we use trigonometry. We use it in proportions and scaling of objects. So it's used in architecture, it's used clearly in music, and slowly, some of you are realizing this math that we're teaching you, it's related to their angles and their ratio of sides. So let's pause the video here. So in this example, we're going to now use how do we find a side? Now, if they give you an angle and one side of the triangle, in this example, I gave you 43 degrees in the angle A, and 9.2 seems to be one of the sides. We're trying to find this side X. And some students don't know what to do, and that's okay. So we have that mnemonic, SOHCAHTOA, right? And this might assist you in what you're going to do to set up. Okay, so again, we're not going to construct this. We're not going to get a protractor and draw 43-degree side angle, a right angle 90 degrees, and a measurement of 9.2 units. We're not going to do that. Again, we're going to use some armchair mathematics. And so in order to find this side, we need to understand what is provided for us or what we need to find out. And I think everyone agrees, I'm going to use green this time if that's okay, that the 9.2 with respect to angle A, because angle A was given to us 43 degrees, this side is clearly the opposite side. And the side that we're trying to find, side X, this is the hypotenuse. Pause the video if you need to a refresher to look at your previous notes. But this will help you to set up what we're going to use. We're not going to use tangent because for tangent, we need the opposite side and adjacent side. We only have the opposite side. So we're not going to use this. We're not going to use cosine because, again, although we want to find the hypotenuse, the adjacent side is still not given to us, so we can't use that. So we're going to use sine to set this up. Now, some of you realize we technically can find this angle. I'm going to put a little purple mark there. We can technically find that because it is a correlated angle. But using the information that's provided for us, we're going to do this. One more time, some students find this difficult. Sine of 43 degrees is a ratio, and I don't really care what that is. But it's basically manipulating fractions. So we're going to multiply both sides by x and divide both sides by sine of 43 degrees. And what we're going to get is x is equal to 9.2 divided by the sine of 43 degrees. And again, if you need me to show the work, I will do that in blue. What we did is we multiplied both sides by x, and we divided both sides by sine of 43. This is why, again, we had to teach you how to deal with rational expressions. I'm just going to erase it because it does distract a little bit. And that's what we get when we rearrange it. Now, what are we going to do? We take out a calculator. And again, hopefully the screen is showing this calculator. I'll clear it, everything. And we simply put in 9.2 divided by the sine of 43 degrees. Notice, even though sine of 43 degrees is a ratio, I don't really want to know what that is. And our answer is approximately 13.489 units. And that's how we find a side. Obviously, sometimes it's easier when the unknown is in the numerator. So we'll do one more example of finding a side. We'll just change this question up just a little bit. Let's just say this angle was 16 degrees. And let's just say this was side y this time. And let's just say we had this unit as, I don't know, 18 units. So again, I like calling this angle A. Pause the video if you need some help. And then, of course, we're going to label this. We'll use a different color just so that people can focus. Side y in this example, this is the adjacent side, and this 18 is the hypotenuse. So what are we going to use? Again, I think a lot of you realize we're not going to use SO because we need an opposite side. We're not going to use tangent. In this example, we're going to use cosine. Watch what we're going to do. Cosine of 16 degrees is equal to y over 18, because the y is the adjacent side and the 18 is the hypotenuse. Notice in this example, a lot of you realize what I'm doing. If we multiply both sides by 18, the 18 is divided on the right-hand side. And I'm just going to erase it because, again, it distracts a little bit. A lot of you realize for this question, y is equal to 18 times the cosine of 16 degrees. Move this up just a little bit. Notice the differences. Notice the similarities to the questions. This was the question to find the side. This is the question to find this side. They look different because the unknown is in the numerator denominator. I should have made this a different color. Sorry about that, ladies and gentlemen. Let's make that y. So taking out our calculator, and again, hopefully everyone can see this on their screen because I'm trying to share it. Let's clear this. We have 18 times the cosine of 16 degrees. A good question is, do we have to put the 16 in brackets? It's good form, but the calculator actually understands to do the trigonometry of that 16 degrees. And again, cosine of 16 degrees, it is a ratio. I don't know what it is, but y is going to be equal to, I just lost it, 17.302 units. Last two examples. Let's just say we have the secondary trig ratios. So let's just say we want to evaluate this question. Evaluate. Let's just say we want to find the cosecant of 41 degrees. Or let's just say we want to find this side. Let's just say we have secant of some angle, angle x, and it's equal to 2.43 units. Some students don't know what to do. So notice there's no buttons on our calculator that have cosecant, secant, cotangent. So to finish this off, cosecant of 41 degrees, we can't solve it directly. However, what is cosecant related to? And I think some of you actually understand what I'm doing. So let me just write the notes here at the top. Sine is related to cosecant because it's the inverse of it. Cosine is related to secant, and cotangent is related to tangent because it's the inverse. So what am I going to do? I think a lot of you, just to teach it for teaching purposes, notice for cosecant, we have to use the relationship of sine. Now, sine of 41 degrees is not going to give us the answer, but 1 over sine of 41 degrees. And let's talk about this one more time. Let's use our example right over here. Let's just break this up. What is sine of 41 degrees? And again, I would not expect you guys to memorize it. So let's just take a look at our calculator. And the sine of 41 degrees is this ratio, 0.656. We'll just use those decimal places, 0.656. Again, this is the ratio of the opposite over hypotenuse, right? Because sine is opposite over hypotenuse. And that ratio is 0.56. So a lot of students find it easier when they do it like this, 656 over 1. If I were to draw a triangle, where would the 0.656 be? It would be on this side. Where would the 1 be? It'd be here. So notice what we want to do for this question. We want to find cosecant. So we want to actually write this ratio. So this answer for cosecant literally is 1 over 0.656. Now notice we don't stop here, right? And so what you're going to do is 1 divided by that answer, and you get 1.524. And this is the answer we're looking for. This is the ratio of the hypotenuse over the opposite. So that's the answer we're looking for. Notice we don't leave it in this stage. Please don't stop here. We go to that 1.524. Notice for cosecant and secant, their answers should be larger than 1. Notice for sine and cosine, notice the ratio should be less than 1. And we'll talk more about that in class. Let's get to this last question. For secant of this angle x, again, you want to find the inverse. So inverse secant, but again, there's no button. So what are you going to do in this case? So I think a lot of you understand that secant is related to cosine. And again, cosine is defined as adjacent over hypotenuse. In this 2.43, it's clearly greater than 1. In this example, this is the hypotenuse over the adjacent. So what are you going to do? Well, a lot of you realize you can change this to 2.43 over 1 and flip it or take the inverse. What does that really mean? The cosine of x is the adjacent over the hypotenuse. So what am I going to do? I'll do 1 over 2.43. Let's pause here for a second. Does that make sense? I think everyone agrees. I just flipped it. So what are you normally going to do? You're going to do the inverse, and that's why they taught you that first, of 1 over 2.43. So you take out your calculator. You do the inverse cosine. Let's clear this for a second. Inverse cosine. Let's try that again. Inverse cosine. It's not writing for me. Let's try that again. Inverse cosine. It's not detecting. Why not? Let's try that again. Inverse cosine. Sorry about that, ladies and gentlemen. And I put these in brackets this time. 1 divided by 2.43. So this is how we're going to find the angle given secant of angle x and do that ratio. And what do we get? X is equal to 65.699. Oops. 699. And that's our answer. I hope this video was helpful, and we'll talk more about it in class. Feel free to refer to your Chapter 5, Section 5.1. Thank you so much for joining us. Have a nice day.